All right, and we are ready to go. So welcome to week number 1, class 2 of cognitive psychology. So what we're going to do today is we're going to continue on with our intro this week, but instead of introing to the course, now we're going to intro some of the basic ideas about cognitive psychology. So we're going to take a look at what the overall approach to this semester is going to be, what the overall approach to cognitive psychology is. How do they think about the mind? How do they think about cognition? And what does that mean for the theories and ideas that we are going to encounter this semester? So again, this is going to be all about how do our minds actually work. And the human mind is one of the most bizarre and complicated things in this universe. And in order to sort of understand it, we need models. We need models of how the mind might work. And the predominant model that we're going to see is the model of the mind as a machine, as a calculating machine, as a computer. Basically, your mind is a computer that is running software which determines what your mind can do. So we're going to use this analogy, we're going to use this model to try to understand how is it that we do a lot of the complex things that we can do. How is it that we do a lot of the simple things that we can do? And as we're going to see, oftentimes the things that come very easy for us are often the hardest to explain in terms of how our mind accomplishes those. And the things that come very difficult to us are oftentimes for psychology the easiest to explain in terms of how do we do those things. So again, this is all going to be about cognition. We're going to do a lot of studies or take a look at a lot of research and theories about how we think, about how we manipulate our thoughts in order to cause the behavior. How do we take in information and then put out information or put out behavior? How does that all happen in our mind? And today we're going to introduce a theory that tries to help explain letter recognition. So something that we can do, recognize letters. It's underpins our ability to read. But we're going to see a theory that takes a look at how do we recognize letters that proposes that we have in our minds demons that enable us to do this. Demons that live in separate rooms and talk to each other sometimes and don't talk to each other other times. And we're going to see how this theory can help us understand how is it that we actually do letter recognition. And spoiler alert, nobody actually believes that you have little demons in your mind. But again, that's going to be the difference between what your mind is actually doing and then how can we actually understand what's going on. So all that and more today when we do our intro to cognitive psychology. So we're going to start off with the very basic fundamental idea that's going to underpin this entire endeavor, which is the information processing approach. We're going to take a look at the requirement, the need for models of the mind, and we're going to take a look at a very influential idea in terms of understanding anything, which is Marr's Trilevel hypothesis. So if you understand something, what does it mean to understand it? Marr identified the 3 things you need to know to fully understand any particular thing. So we'll talk about Marr's Trilevel hypothesis. We'll talk about the idea of a representation and what is a representation. And then we're going to turn to 2 models of letter recognition just so that you can see the importance of representation and how different representations could lead to different behavior. So we'll take a look at how letters are recognized, and we'll introduce that demon model, that Pendemonium Model, which is actually highly effective at explaining how is it that we do that letter recognition task. All right, so off to thinking. Before you start trying to explain anything, before you start to try to understand anything, you need to define or understand what that thing is. So before we can understand cognition, we need to have a working definition of what is cognition, what is thinking, what is this psychology of cognition that we're actually studying. And for cognitive psychology, they have adopted an overall approach known as the information processing approach. So to a psychologist, thinking is processing information. So human cognition, what we think of as thinking, can be thought of as information processing. That's what it basically boils down to. And if you can understand how that information is processed, you can understand human cognition. So in this case, the mind is thought as an information processing system. And what we have is we have information that is incoming into the system that your mind takes in through various channels. And then it processes that information into another form. And then it has the potential to output that information either as new information or as new behavior. So this information processing approach, to take a look at it in more visual form, if you have your mind, which we do, that was a weird thing to say, but you have your mind, and there's a world out there that is sending your mind information. And the information that it might send you is that there are two vertical lines in the outside world. So that information gets sent into your mind. And it might also let you know that there are two slanted lines in the outside world. And that information gets sent into your mind. And there are two horizontal lines in the outside world. And that information gets sent in. And there are two other slanted lines, slanted in the different direction in the outside world. And that information gets sent in. So we have these 8 pieces of information about lines in the outside world. We can also then get information from the outside world, again, information coming into the mind, about the location of these particular lines. So those top 2 vertical lines are in those 2 locations. And those slanted lines are in those 2 locations. And the horizontal lines are in those 2 locations. And the other slanted lines are in those 2 locations. So we have slant information, orientation information, we got location information, and we might also get color information. We might get that the color red is extended within this area, and that gets sent into your mind. And your mind takes in all of this information, processes all of that information, and comes to the conclusion that it is looking at a red octagon. So all of that information processed together, lumped together, leads your mind to conclude that what is outside in the world is that red octagon. You then continue to process that. You combine what is outside in the world with information from your memory. So information that you have stored from previous encounters with the world. You combine those two and you come to the conclusion that you are looking at a stop sign. And you then come to the conclusion that you should change your behavior and you should probably stop. So that's the essence of that information in, information out approach, that information processing approach. What we're going to do in this course is we're going to analyze what is the information that is coming in to the system, what is the information that comes out of the system, and psychologists use those 2 starting and end points to try to figure out what happened in the middle. What did your mind do to get from input to output? And again, the idea is going to be that your mind works like a machine. It works on these representations of information, and it crunches them much like a computer would. It manipulates them much like a computer would, and that is the essence of what cognition really is. All right, so once we have that idea of information in, information out, we've already sort of talked about this mind as a computer metaphor, and this leads us right into this idea of models of the mind. So, as I mentioned before, the mind is an incredibly complicated thing. And we're not even talking about the brain, which is massively complicated. We're talking about next level complicated and next level weird and next level difficult to study, which is the mind. So if you ever want to know just how hard it is to study the mind, just know that psychology for a period of time during behaviorism quit studying the mind. They literally said, it's too hard, forget it, let's do something else. And I don't know another science that ever took a look at the universe and said, it's too hard, let's not do that anymore. That'll give you an indication of just how weird and wonderful the mind is. So we need models. We just can't understand the whole thing at once. We need models for the mind. So this is going to be, again, this idea of a representation of how your mind works. It's not saying that your mind is the model, but it's saying that your mind is like the model, that the model can help us understand how the actual complicated thing really works. So the advantages of models, the first advantage is that they are much, much simpler. So you can take something that's incredibly complicated and you can simplify it to a point where we have a chance at understanding it. So if you were to look at the world, if you were looking down from space and you were looking at the world, you might see something that looks like this. And if I was to ask you a question about the world, and I was to ask you, well, when you're looking at the world, where's Canada and where's the United States? In this world, where's Canada and where's the United States? Draw me the border between Canada and the United States. Given this rather complicated map of the world, all right? So given this model of the world, so we're not looking at the real world, this is a model of the world, this is a picture of the world, that question is incredibly difficult to do. And we kind of know that this is the United States, and we kind of know that this is Canada, and we remember that this is the United States as well up here. But where exactly are these borders? It's hard. It's hard with this particular model. A little bit easier with this model over here. Now it gets a little bit easier to delineate what's Canada and what is the United States. So by simplifying the model, by not having as much detail, by simplifying what we're using to represent the real world, we can start getting a little bit closer to the actual answers. And if you simplify the model a little bit more, then you can get very close to the actual answers and things start to become apparent. So that's the power of models. That's what we're going to be working on in this entire semester. We're going to be working on models of the mind. What are these sort of simplified versions that psychologists have come up with to try to understand how our mind does what it is that it actually can do? So that is one of the advantages of the models. They are actually simpler. The other advantage is that they oftentimes serve as a starting point. So they're oftentimes you're in to try to understand different aspects of the mind. So that starting point can oftentimes help you suggest the right kind of questions, suggest the right kind of ideas to ask for. And we're going to see this in an example today when we take a look at the Pandemonium Model. But basically, once you have a hold of the model, it oftentimes can reveal questions that you never even thought of asking before. So, for example, one of the big new models, new representations of the mind came in psychoanalysis when Freud said, well, what if your mind is like an iceberg? And here's my model of the mind. It's like an iceberg. And the top little part that's popping up, that's your conscious aspect, and that's your id. And everything below is this super huge part of your mind that's called the ego, but it's unconscious. You don't have access to it. Number one, that radically changed how everybody understood the mind. All of a sudden you have unconscious mental processes. That was unheard of. That was something that nobody thought, could be true. Of course you have access to your mind. It's yours. You can introspect into it. But then that started to suggest questions, like how much of our behavior are we not aware of? How much of our motivations are we not aware of? What about dreams? Might they have these secret, unaware wishes that we don't know about? All of these questions became possible because this new model of this unconscious section of your mind was suggested. And then models, as we've alluded to, they can be used to understand this information processing system. That is, they can be used to understand your mind. So just bear that in mind. Never lose sight of the fact that we are going to be talking about lots of models in this class. Models on how we can accomplish attention. Models on how we can do visual perception. Models on how we can understand language. Models on how we can make decisions. And they're all simplified versions of what we think might be the things that your brain is doing. Sorry, that your mind is doing. We're going to get to the brain and the mind right now. So any questions about that? basic idea? All right. So, one thing that's really going to help us this semester to kind of keep focus where we need to keep focus is Marr's Trilevel hypothesis. So this is named, this was proposed by a researcher, Marr. He was in perception. He had massive impact in perception. Unfortunately, he died very young, I believe at the age of 34, before his career could have been the great, super influential career that it was. But he did make a lot of innovations, a lot of contributions, one of them being Marr's Trilevel hypothesis. So he proposed that if you want to fully understand an information processing system, you have to understand it at 3 distinct levels of analysis. You have to understand these 3 things about your information processing system. So what are those 3 things? Number 1, you have to understand it at the computational level. The computational level is the problem that is faced, and this is usually stated in conceptual terms. To paraphrase this is kind of a little difficult to understand. This computational level is the level at which you describe every single thing that your information processing system can do. So in this computational level, if we were trying to understand the human mind, if we wanted to say cognitive psychology is about the understanding of the human mind, and we want to know when is cognitive psychology finished, right? When are we going to be able to say, we got it, we understand the human mind? Well, one thing that we have to finish is we have to finish the computational level. We have to specify everything that our mind can actually do. So, what can our mind do? Well, we can see objects, right? We can look out into the world and see objects. That's one thing in the computational level. We can navigate a room, right? We can move around a room without running into furniture. That's a second thing that we can do. We can remember things that occurred in the past. That's a third thing. We can plan for the future. That's a fourth thing. We can read. That's a fifth thing. We can talk languages. That's a sixth thing. We can talk multiple languages for some of us. That's a seventh thing. We can recognize letters. That's number 8. We can count to 1,000. Hopefully, that's number 9. There's hundreds of thousands of things that we can do. That's the computational level. So if we ever want to have a complete understanding of what our mind is, first, we're going to need to know everything that our mind can do. And we're probably very close in doing this. No single person probably has this list, but we kind of know what we are able and unable to do. We keep discovering some new things, but pretty much that is your computational level. What can your information processing system do? Your next level is the representation level. And this is where we're going to camp out this semester. The representational level is the strategies that might be used in computational terms. So the representational level mentions the strategies, the steps, the processes, the representations, the symbols, the formulas, whatever it is that might be used to accomplish this computational level. So for example, one of the things in the computational level is that we can put letters in order, right? We can put letters into alphabetical order. So if you had chalk, there it is. Computational level. You can find chalk in a classroom. Something else we can do. All right, so let's say that you had a list of letters, and it was B, C, G, E, Q. All right, if I asked you to put that in alphabetical order, everybody here would be able to put that into alphabetical order. So we have that as a computational level. We can do that. How do we do that? Well, as it turns out, there's a number of different strategies that you can do for this. And if you are in computer programming, you will know that there are, at least 5 distinct ones about how to order a list. So I'm just going to show you 2. One is the insertion method. And what that says is you start with the first letter and you put it into a new list. So the first one is B. You then go to the second letter and you go down the list until you come to a letter that is higher than it actually is, right? And if it's not higher, it goes to the end of the list. So you start with C. C is higher than B. C gets to the end of the list. You put a C there. You then go to G. You start over here. G is higher than B. G is higher than C. You get to the end of the list. There goes G. You then go to E. E is higher than B. E is higher than C. E is not higher than G. So you would stick that one right in there. And then you do Q. You do the same thing. And you end up at the back. That's an insertion sort. That's one strategy that our mind might be using. There's another way to do this called a bubble sort. And what you do in a bubble sort is you take a look at the two letters and you ask, are they in the right order? If they are, you leave them. If they're not, you switch them. So B and C, are those in the right order? Yes, you leave them. C and G, are those in the right order? Whoops. Yes, you leave them. G and E, are those in the right order? No. You switch them. G and Q, are those in the right order? Yes, you leave them. You would then start with the next one over, and you would have to go through until you went. I picked a weird list. But anyways, that's another way to do it. Two very different strategies in terms of how do we actually solve this problem. So the representational level is coming up with these strategies that may be used. Coming up with strategies like, oh, maybe we organize or we alphabetize letters using an insertion method. Maybe we alphabetize letters using a bubble sort. Maybe we alphabetize letters using any number of these different strategies. That's your representational level. And what psychologists in cognitive psychology do is they come up with these representational levels, and then they do experiments to choose between the ones that you actually do. And we're going to see a little bit of that on the letter sort. Sorry, on the letter recognition. So that's the representational level, the strategies that may be used in computational terms. And then the final level of explanation that we need to say that we completely understand an information processing system is the implementation level. And that is, how do you actually physically do this in a real entity, in a real thing, in a real physical thing? How do you do this? And this is basically neuropsychology. This is basically the study of how do the axons and dendrons and synapses and connections and lobes and everything in your brain, and also parts of your body, if that's the embedded body hypothesis, and also your environment, that's the extended mind hypothesis. How do they all come together in a real physical thing in order to do that representational level? And if you have all three, you will have a complete understanding of information processing. You'll have a complete understanding of the mind. So in the neuropsychology course, if you took behavioral neuroscience here, or you took maybe sensation and perception, we'll have a little bit of this, you might have spent some time at the implementation level. We're not going to spend time at the implementation level. We are going to be at the representational level, talking about the strategies and the evidence for those strategies that we have in terms of how our mind works. So another way to think about this is that the computational level is what can we do. The representational level is how does our mind do it? How does this theoretical entity that we call the mind actually accomplish that? And the implementational level is how does our brain do it? How does this physical thing that exists in the world accomplish that thinking information processing? All right, any questions on that so far? All right. So the representational level, that's what we're going to stand on. That's what we're going to spend this semester. So what representations does the system use? What representation does our mind use is a very important question. And then what processes does it use to build on those representations, to manipulate those representations? This is basically the core of what cognitive psychology is all about. So this idea of representation, we've been playing a little fast and loose with it. So it's going to be time now to decide and kind of define a little bit what exactly is this representation. What is this idea of, oh, our mind is using representations. Our mind manipulates representations. What sort of representations does our mind use? What do we mean by all this? Well, all that a representation is, it's a hypothetical symbol, but it's an internal symbol. It's a hypothetical symbol that your mind uses, and it represents or stands in for some sort of external reality. So it's something in your mind that is standing in for something that really exists. So, for example, you might have the external reality of a stop sign, right? A stop sign might exist in the external real world. And somewhere in your mind, you have coded that and represented that stop sign with internal symbols. And our job as psychologists is to figure out what are those internal symbols. So it's quite possible that these are those internal symbols. But the challenge in cognitive psychology, and the reason why we're not done yet, is that we don't have direct access to what these representations are, and there are so many different possible types of representations, and we got to find the one that our human mind actually uses. So that is something that is a basic challenge, and just to kind of illustrate that idea that you have this variety of different symbols, let's say that you're trying to represent the external reality, and you're trying to represent the external reality of two-ness. You're trying to represent the external reality of two things. So here we have two fish, so you can represent the fact that they are fish, but also in your mind, to understand the number of fish, you got to represent that there are two fish. So you got to represent the idea of two, you got to represent two-ness in your mind somehow. How do we do that? Well, there's a variety of different internal symbols that can get that job done. So we have the numerical 2, right? Maybe this is a representation that your mind is using to stand in for this, right? Maybe this is your internal symbol that refers to that. Or maybe this is your internal symbol. Maybe 2 dots is how your mind represents the idea of there being 2 of something. Or maybe this is your mind's internal symbol. And if you're a computer programmer, you'll know exactly why that is an internal symbol for 2. So it's quite possible to represent this external reality in a number of different ways. And our mind is going to do it in a specific way. Our human minds are doing this representation in a certain way, and our job as psychologists is to figure out, first off, which way. What is the way that our mind is representing that idea of two-ness? So this is, at first glance, might be a little bit difficult to understand just how challenging this can be. There was a massive debate, and it's still going on in terms of how your mind actually represents things. So let's say that this is the external reality that we're trying to represent. So that's your external orientation and location of different cities in the United States. And here's an internal symbol. And maybe this is the way that your mind represents where Los Angeles is, where Dallas is, and where New York is. Maybe that is the way that it represents distances between Dallas, New York, and Los Angeles. So this is one possible internal symbol. This is another possible internal symbol. As you just have Los Angeles to New York, 2,790 miles. New York to Dallas, 1,547 miles. Maybe that's the way that your mind represents distances. So it could be this way, it could be this way. And what a cognitive psychologist would do is they would run experiments to try to figure out which way do you actually represent the distances between these different cities. So you might ask somebody, well, what is the distance between Los Angeles and New York? As quick as you can, what's the distance between Los Angeles and New York? And that person, if they were using this representation, would very quickly and very accurately say 2,790 miles. They would have that answer like that. If they were using this representation, it would take longer, and it wouldn't be as accurate, right? They would go, well, that in my mind looks to be about, I don't know, let's call it 2,800. We'll just do that. It's going to take them longer, and they're going to be less accurate. And sometimes representations make certain things possible or impossible. So if you were to ask to this person, if you're going to ask this person, which one of those cities is the furthest south? This person would be able to consult their internal representation and say, oh, it's Dallas. Dallas is the most southern of those 3 cities. This person over here, which one is the furthest south? They would answer, what's south? I don't know. I know the distances, but I don't have a representation of their orientation. So again, the representation is important. It impacts behavior. It changes what behavior is possible. And it's our job as psychologists to try to understand what representations we might be using. So that idea of representations making behavior and cognition possible, we've already experienced that last class. So it was very important in terms of how you represented this train problem in terms of whether or not you could solve it. And by analyzing who was able to solve it and who wasn't able to solve it, I could tell as a psychologist who represented this as a distance problem, in which case you weren't able to solve it, and who represented it as a time problem, in which case you were able to solve it. So different representations can lead to different behaviors. So we need to know, as psychologists, what representations does our system use, and then what processes does it use to manipulate those representations. So when information comes in, how is that information represented? How is it coded? How are those representations then manipulated so you can get information out? All right, so any questions on that basic idea? Okay, so let's take a look at some representations from psychology. We're going to take a look at 2 models that were proposed for how our minds accomplish letter recognition. So if you wanted to understand letter recognition, if you wanted to say, I have a complete understanding of letter recognition, one of the first things that you would need to do is you would need to answer at the computational level, what kind of letter recognition can we do? So we might start out with a little test. So call out the letter as soon as you're able to recognize it. All right, so we know that our human minds can recognize R, F, Z, and P, right? So that's the computational level. We need to know what we can do first. Now the question becomes, how do we actually recognize these letters? How do we recognize the letter R, for example? What sort of representations and what sort of processes are being used? So let's take a look at one proposal. This was known as the template model. And this is what they proposed for level 2 of Marr's Trilevel hypothesis. This is the representational level. And again, that's where we're going to end our look into the mind in this course. We're not going to go beyond representation. We're not going to talk about the brain. We're going to stop at the representational level. And that's our goal for cognitive psychology. So this is a representation of how your mind might work. You have this external reality, this external stimulus, you have this R. That R gets placed into an image sensor. So that image sensor takes in that external information, and then that image sensor sends that information, sends that representation to a template. And this template has a list of all the different letters and numbers, capital and small letters, that you can recognize. So this is your internal storage of representations, and then it will output whether or not you found the letter that you were, or whether or not you recognized what you were looking at. So this is the way that the model works in action. So you have this R, you encounter it in the external world, that R gets sent in to the image processor, and then that image processor is going to be compared to everything in your template. And your mind takes a look at your template and it says, all right, let me start up here, and I'm going to look for something that's in my template that matches what this image over here is. So it starts looking, nothing, 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 oh wait, there it is. We got something. So if what's in your image is found in your template, and basically it has to match up exactly. So if what's in your image is found in your template, you then make the decision that, yep, I recognize this, and that is what we call R. That is the way that we recognize R's. So that's the template model of letter recognition, and it very simply and very straightforwardly can explain how we recognize this R that we all can do, right? So we all can recognize this. This is one possible way that we achieve that recognition. So far, so good? All right, that's one possible representation. Let's take a look at another possible representation. This is the Pandemonium Model. So the Pendemonium Model, this was proposed by Selfridge back in 1959. And what he proposed is that if you have an R, what happens to that R is that it, once again, it gets sent into an image detector, but this time we have an image daemon. So once again, this is the representational level. This is a potential way that your mind is solving this computational level challenge. Maybe, potentially, we have a daemon in our mind that is known as an image daemon. And that image daemon sends what they see to this TV screen that is located in this room. And that room is filled with feature daemons. And those feature daemons have certain features on their bellies, and if they see the feature that's on their belly on that TV screen, then they get hot and agitated. They get angry. And when they get angry, they got to let somebody know. And who do they let know? Well, they let the cognitive demons know. So these image demons, these feature demons, they will contact these cognitive demons. And these cognitive demons have the letters that you can recognize. So there's your R daemon, there's your P daemon, there's your F daemon, and there's your Z daemon. And then these demons, if they get activated, will tell a decision daemon what it is that they found, what it is that they think they're looking at. Now, the last part of this model that we need is the fact that these feature demons are not allowed to talk to all of these cognitive demons. These feature demons only have connections to certain cognitive demons, right? It's like they all have cell phones, but they only have certain people in their contact list. So for example, this demon over here, it can talk to the R daemon, it can talk to the P daemon, and it can talk to the F daemon, but it does not have the contact information for the Z daemon. Can't talk to it. This demon over here can talk to the R daemon, can talk to the P daemon, but not allowed to talk to F, and not allowed to talk to Z. This demon over here talks to the Z daemon and only has contact information for the Z daemon. And then this one over here talks to the R daemon and only has contact information for the R daemon. That only has contact information for the R daemon. All right, so there's your model for letter recognition. How does this accomplish recognizing the letter R? Well, what happens is when you encounter that external reality, you encounter that R, it gets picked up by the image daemon. So there it is on the image daemon's belly. Image daemon sends it to the TV screen, gets projected into the room. Each of these images, each of these feature daemons starts looking at the TV screen, and again, they get hot and agitated if they see the feature that's on their stomach reproduced on that screen. So this image daemon that has this vertical line says, I see a vertical line. Look, it's right there. And they start getting very, very angry. And when they get angry, they got to tell somebody about it. So they start texting their cognitive demons that they're connected to. So they send a message to F, and they say, I'm really hot and bothered. And they send a message to P, and they say, I'm really hot and bothered. And they send a message to R, and they go, I'm really hot and bothered. So R, P, and F have now received messages from one of their feature demons. And then this demon over here, with the curve on their belly, says, you know what, look at that. Look at that curve right there. I can't believe it. Hot and bothered. I got to tell somebody. So they tell cognitive demon P, and they are connected to cognitive demon R. So they send two messages to these demons, let them know, I'm really hot and agitated right now, super hot and bothered. This demon over here takes a look at the TV and says, you know what, I'm fine. I'm cool. There's nothing really there for me. I'm not angry at all. Doesn't contact anybody. And then we got this feature daemon over here, and this feature daemon says, oh my gosh, look at that. Look at that slant right there. Can't believe it. Hot and bothered. Got to tell somebody, sends a text off to R, and it goes, you know what, I'm really agitated. I'm really hot and bothered. At this point, after all the messages are received, this decision daemon is looking in on this cognitive daemon room. And these cognitive daemons start comparing how many people they've heard complaints from. So the R daemon says, wow, something must be going on in the feature daemon room, because I got messages from 3 daemons. 3 people contacted me that they are hot and bothered. And P says, you know what, something must be going on in there, but I only got 2. I only got 2 messages. The F daemon says, yeah, something's going on, but I only got 1. I only got 1 message from, the feature daemon room. And daemon Z over here basically says, I didn't know anything was going on. I got no messages whatsoever. So this decision daemon is looking in, and he looks at who got the most messages, and in this case, it turns out to be R, and the decision daemon says, oh, okay, if R got the most messages, we're looking at an R. And there you have the Pandemonium, aka daemon model, of letter recognition. Any questions about that one? All right, so far we have 2 separate models. 2 models that are equally good at explaining how do we see and recognize this letter over here. How do we recognize this R? So we need a way to distinguish between those 2 models. And historically, what happened was that people started asking, well, how do we recognize the letter R, but in different fonts? So first off, is this something that we can actually do? Can we actually recognize letters in different fonts? So we take a look at that letter over there. What's that letter? R. It's an R, so we can do that. That one. That one. And that one. All right, so we can definitely recognize letters that are portrayed in different fonts. And as it turns out, this was a major challenge for the template model. This was something that the template model really struggled with, because if you looked at the formulation of the template model, in this case, what would happen is that you would see this external reality, and it would get sent into your image processor. And then that would activate your template, and your template would search. And again, this is the key to the template model. Your template would search for the matching template entry. It would search for the exact same type of font. That's the key one here, because this was the template model, and they were using the idea of that template that you use to stamp things in a machine factory as their model for how your mind works. So it had to line up exactly. So in this case, you would start your search, and you would search and search and search and search and search, and you would say, well, that's kind of close, but it's not an exact match, so let me keep searching and search and search, and you would come up with no match. Your decision would be, I have no idea what I'm looking at. So this model predicts that if you are given a new font, you would not be able to recognize that letter R. So clearly, this model fails in terms of letter recognition. Now, people did try to say, well, what if you have another template for this font? And they were like, all right, but what about every other font? Well, what if you have templates for all those other fonts? And they would say, well, all right, well, what about a new font that you've never seen before? And people just kept stumbling in terms of trying to explain letter recognition with the template model. And the template model was eventually abandoned because it failed on things that we could do. So if it's in the computational level, if it's something that we can do, and our representational level says that we can't do it, then our representational level is wrong. We need to find a new representation. And then this is where the Pendemonium model really showed its strength. So once again, we have our Pendemonium model. We'll set it up this time for this font over here. So once again, we have our image daemon. We have our feature daemon room filled with feature daemons. with different symbols on their bellies. They get hot and bothered when they see that in the TV screen. We have cognitive demons that have letters on their bellies, and they're your letter recognizers. We have a decision demon that makes the final decision, and we have connections between only certain feature demons and only certain cognitive demons. So that is the model right there. So what happens with this new font? Well, the font gets picked up, the R gets picked up by the image demon. The image demon says, oh, here's this external reality. Let me represent it. Let me put it up here on this screen. And now what happens in the feature demon room is that this demon over here says, ooh, I don't like vertical lines. And look at that vertical line right there. Oh my gosh, I am hot and bothered. And I got to tell somebody about it. So it sends a message to F, sends a message to P, and sends a message to R. This demon over here says, I don't like curved lines. And look at that curved line over there, hot and bothered. And I got to tell somebody. So it sends a message to P, sends a message to R. The next demon over here, this one, says, oh, I don't like forward slanted lines. I don't see any, I'm fine. And this one over here says, I don't like back slanted lines. And look at that one right there. Oh my gosh, hot and bothered, gotta tell somebody. And it phones up R and lets R know that it is agitated. In this case, once again, we have R saying, I don't know what's going on, but 3 feature demons have contacted me saying that they are very, very angry. And the P demon says, oh, I only got messages from 2. And the F demon says, I only got messages from 1. And the Z demon says, I didn't even know there was a problem. And the decision demon is looking in on this and says, well, R is getting the most complaints, so we must be looking at an R. So the Pandemonium model helps us to understand how it is that we can recognize letters, and it works with different fonts. So it works with anything that can be picked up that has the orientation of the lines that signal to us that we're looking at a particular letter. Any questions about that analysis? Yep.
Why does the template model not let you do like a rough? You know, like why doesn't in that model of thought, why wouldn't your brain just in that like different font case, why would it just be like, oh, that's close enough, therefore that must be the answer?
That's a good question. So the question, in case you couldn't hear it, was why in the template model were they not allowed to be close enough? Right? Why in the template model were they not allowed to basically do what was done here in the demon model, where it says, well, this is an up and down line, and here I see an up and down line, versus, well, here's an up and down line, and this is kind of up and down, but I'm not really bothered by it. So why is it allowed in one model and not allowed in the other? And this is kind of one of the, I would say, limitations of using models. So models are they're very helpful, but sometimes they kind of limit your thinking about an idea. And this template model was taking, they're basing their model on the idea of machinery and templates for machinery. So literally like in a factory where you would stamp things out with a particular template. And in order for what's being stamped to match up with the template, it has to be exact. So that was kind of built into the model because it was borrowing from those features of the template idea. So when they said, well, how do we recognize these new fonts? That was a good question, and the model itself led them to say, well, it's got to be another template because we need that exact match. That's how we're doing this. So that's when the model kind of fell through, and they said we just need to keep having these extra templates, was when it just kind of fell apart. Now, we're going to see later on in this course that idea of kind of close enough is actually one of the things that's being used in artificial intelligence and in machine learning, where this idea of close enough is exactly how that decision is made. And it's also one of the things that happens with models is that models get used, and then if they don't quite fit, they get discarded. And oftentimes they get manipulated, but sometimes, and that is a good point, sometimes it's almost like you get trapped into thinking about the model, and you get trapped in the features of the model, and you don't allow yourself to think of certain things. So as much as models are very helpful because they allow you to ask the right questions, sometimes you have to be aware that you are using a model. Sometimes they will obscure or blind you to other features that you could use. Any other questions about the letter recognitions? All right. So to kind of wrap up what we're looking at today, so just to give you a synopsis of what we just went through, we took a look at what we could do. We could recognize R. That's your computational level. And then the template model and the Pendemonium model, we tested them to see if they match up with our computational level. So we can recognize the letter R, and the template model, an R that looks like that. And the template model said, yep, we can recognize R, and this is how we do it. And the Pendemonium model said, yep, we can recognize R, this is how we do it. What else can we do? Well, we can recognize R done in this font. And the template model says, nope, we can't recognize that R. And the Pendemonium model says, yep, we can recognize that R. So in this case, this is evidence that the representation that we are using to recognize the letter R might be described by the Pendemonium model. But for sure, we know that it's not described by the template model, because the template model is not matching up with what we can actually do. So the Pendemonium model might be the way that we represent it. The challenge continues to be that there's a number of other different models that can also account for how we recognize letters. So we continually test to try to get to the truth of the matter. But definitely we can eliminate the template model. We don't need that exact match, and we don't match it up to our memory that we've already seen of these particular letters. All right, so letter recognition. I mentioned before that the models that you work with, they suggest questions that you can ask, right? They suggest things, inquiries, directions for research that you might undertake. That's one of the things that good models will help you do about the mind. So questions that we can ask with our Pendemonium model, and this I'm going to leave as a kind of take-home assignment where we'll take it up in class next time, just to kind of make sure that you know how to navigate the Pendemonium model. But this Pendemonium model, as it is, so as it is listed in your lecture notes, we can ask the question, will there be confusion when you're looking at the letter P? So go through the steps of the Pendemonium model and try to decide, given this Pendemonium model, so this is a simplified version of it, but given this simplified version of it, if a P is out there in the real world, will this decision demon be able to make a decision as to who has the most calls coming in, who has the most people complaining to them? So that's question number one. And then another question that we can ask with this Pendemonium model, and this is one of the reasons it really took off, is what happens to some connections? What happens if we lose some of these connections due to brain trauma, right? So will there be confusion when looking at R? So for this one, we're going to be using an impaired version of this model. So this is the fully functioning model over here. So what would happen if we had a brain injury, and because of the brain injury, we lost that connection right there? So what would happen to our ability to recognize R if we had an injury that led to a loss of that particular connection right there? So work through the model and see if we can still recognize R, or are we now going to be confused when we're taking a look at R. And we're going to end today with one last kind of insight into the Pendemonium model. So I mentioned that the Pendemonium model kind of took off and that this architecture took off. This was done in like 1959, and that's an important kind of period to remember. So this was done when the amount of computational power in the world is far less than what you're holding in your hand if you have a cell phone, and way less than if you're working on a laptop right now. So the idea of these sort of like network connected computers that we have right now, that idea as a model was not there. So first off, this is massively innovative because it kind of foresaw the connectionist models that are now underlying artificial intelligence. But also, very importantly, one of the huge challenges that psychology faces is going from the representational stage to the implementation stage. It's a huge challenge to say, this is how things are represented, this is how it's actually done in the brain. And when you're looking at something like the template model, and you're asking yourself, how could neurons, how could connections possibly represent a template, right? What sort of number of, like what kind of connection pattern do we need to represent a template that has all these different fonts in it? It kind of boggles the mind. It's kind of outside our realm of understanding. However, when you take a look at this, all of a sudden you start to see possible connections for how we can implement this. So it is not that far of a stretch to say that these connections, maybe those are neurons, right? And maybe different connected neurons from your visual cortex connect to neurons in maybe your temporal lobe. And it's a lot easier to go from this model to implementation than from other models to implementation. So that's also part of the reason why I think it was very accepted in terms of this architecture. And it really is kind of continuing along this line. When you finally, if you don't already, have a self-driving car, or if you have Siri or Google Home or Alexa at home, you can thank this type of work in Selfridge for those ideas of connected processing that's making all this possible. All right, any final questions or comments about anything? Yep.
So you mentioned with the brain trauma that some of those connections would be broken.
Yep.
Is the same kind of idea, would that be applied to a learning disability like dyslexia, where the model's kind of messed up, or?
Absolutely, yeah. So, for example, that's a great point. What you can do is, again, models help you understand what might be going on with different individuals. And if you have a model like this, and then you have somebody who has dyslexia, first thing you're going to want to do, get the computational level. So I'm not an expert in dyslexia, I don't know all the symptoms, but you would want to know what their reading abilities, for example, are. And then you could take a look at this model, and you can say, what would cause those specific reading disabilities? Is it, or reading impairments, is it that some of the feature demons are missing? Is it that the feature demons are connected to the wrong cognitive demons? Are some of the cognitive demons missing? Is it the fact that the TV is not bright enough, it's impaired? All of these questions kind of can lead you to the correct answer. And what people would do is they would say, well, let me take a look at what happens if we remove one of the feature demons. And then they would run possible examples through the model, and they would say, all right, does what the model predicts should happen, is that actually what dyslexic individuals do? And if it is, it's a new possible insight into how they operate. If it's not, then we know that's not what the issue is, and you try another approach. Mm-hmm. Any other questions? All right, so that is it for today. So make sure that you're staying on top of your syllabus, your due dates. We are starting to get into the chapters next week, so stay on top of your pre-tests, stay on top of your quizzes. One of them is in Canvas. Make sure that you do that one as well. But other than that, we are done for today.